Aloha everybody, this is Gigi from Kauai Community College. In this video series, we will be talking about graphing by transformation. It will probably be about 4 parts, so make sure you watch them in order, okay? Part 1 on shifting functions. So when we talk about graphing by transformation, the most important part is what we call the parent graph. What's a parent graph? It's the most basic of its kind. For example, if we were talking about absolute value graphs, the most basic one is the absolute value of x, right? So let's go ahead and plot some points to see what the pattern is for the parent graph of absolute value of x. I'm going to go ahead and pick 0 because that's right in the middle, the origin. The absolute value of 0 is 0. When x is 1, the absolute value of 1 is the distance from 1 to 0, which is 1 unit. The distance from 2 to 0 is 2 units. And if you continue, you'll say you will have the point 0.33, and you can generalize it by saying the absolute value of a positive number is itself. And you have heard me say that before, right? And then when you go on the other side of 0 to the left-hand side, when x is -1, the absolute value of -1 is 1 because -1 is 1 unit away from 0, just happened to be to the left of 0. Okay, and then the absolute value of -2 is 2. And the absolute value of -3 is 3, and so on. And we can say that the absolute value of negative numbers will be a positive number, meaning it's opposite, right? So absolute value of positive stays positive, absolute value of negative becomes positive. How does that affect the graph? Visualize it for a second here. It's going to make a V shape, just like that, where the vertex is 0, 0. The vertex is 0, 0. And then you would go over 1, up 1, over 2, up 2. To the left-hand side, if we go left 1, the absolute value of -1 is 1. So left 1, up 1, left 2, up 2, and left 3, up 3, and so on. But for this class, I would like for you to have these five points as your reference point. Okay, so for absolute value graph, 5 points would be enough. All right, now we are going to go ahead and take a look at what happened when we add on a number to this function, to this absolute value. Now, when I add on a number to this absolute value function, I could add it inside the absolute value, or I could add it to outside of the absolute value, right? The question is, how does that affect the graph here, this parent graph here? And to see that, I will take you out to Desmos, and then we'll take a look. All right, so here we are in Desmos. What happened if I say, here's the absolute value of f of x, as you have seen, that's the parent graph. What happened to this graph if I say plus 2 to this graph? Oh, what just happened there? It just got moved up 2 units. It was here, and then it got moved up 2 units. Okay, so plus 2 moved up the graph. What happened when you say minus 3? What happened to the graph? It got moved down 2 units. 3 units, actually, right? Now, as a matter of fact, I'm going to just leave that green one right there, and I'm going to make a different color, f of x, so you can compare that a little bit better, is equal to, and in this case, I'm going to go ahead and say x, absolute value, and I'm going to add a k at the end, just so I can add the slider and you can see what will happen to the graph. What happened when I add to the outside of the function? The graph move up and down, right? Now, if I am going to subtract, then the graph will move down. But as far as the shape goes, it still is the same shape, meaning over 1, up 1, over 2, up 2, the same pattern. All right, so adding k actually move on the outside, the number on the outside will move it, the graph up or down. Now, what happened, I'm going to go ahead and put a slider here. What happened if I add a number, say I'm going to call that h here. What happened if I add I'm going to move it back to normal here. Let's move this back to normal, meaning now they're both at 0, 0, h and k, so that there is no movement at all, right? That's just the normal absolute value of x. Okay, now we already know that, let's say if I was to have minus 2 at the end, the graph is going to move 2 units down, right? Now, my question is, what happened, okay, what happened when the h is positive, and what happened when the h is negative? Okay, what happened when h is positive? If h is positive, where does it move? To the left. If h is positive, the graph moves to the left. What happened when h is negative? The graph moves to the right. Look at that. All right, so we have two things going on here. The h, which is the number inside, does the opposite. If it's positive, it's going to shift to the left. If it's negative, it's going to shift to the right, right? And then the number on the outside is going to do as it said. If k is positive, it's going to move up. Whereas if k is negative, it's going to move down. All right? So what do you think if I'm going to go ahead and take the sliders away. What do you think if h is 2 and k is, let's say h is 2 and k is 3. So this is going to move to the left 2, and left 2 and up 3. So we have a new graph with the vertex at -2, +3. There's the new vertex right there. All right. So that is how we shift a function. Now, does it matter if it is, instead of absolute value, you have something different? And say something like f of x is equal to x squared. Well, let's first take a look at the parent graph. All right, let's take a look at the parent graph of x squared. You've seen this before. It's going to make a U shape, right? But just slowly do this one more time now with me. 0. Ooh, that should be not, that shouldn't be, it should be actually be x squared instead of absolute value of x. So 1 squared is going to be 1. And then 2 squared is going to be 4. On the left-hand side, -1 squared, which is -1 times -1, is going to be +1. And then negative 2 to the second power is going to be 4. And we know that this, we want to say this is x squared, not absolute value of x. All right. So the parent graph is going to look like this. And so the pattern for this U shape is going to be 0, 0 with your vertex, over 1, up 1, that makes it 1, 1, over 2, up 4, because 2 squared is 4. To the left, negative number square up will give you a positive number, so over left 1, up 1, left 2, up 4, because negative 2 squared is 4. Now, the same thing will happen, I would hope, and I'm going to take you over to decimal again to see how transformation work for this parabola-looking shape. All right, here we are in decimal. This is x squared. Okay, now earlier we saw that adding a number to the n outside of the absolute value would move the v up so many units. Well, what happened if we add, say, 3 to this x squared, like on the outside of the x squared? The graph just moved up 3 units, just like the v, right? So it's working the same way. What matter is it outside or is it inside, right? Now, what happened now inside, if I say instead of x, let's say I have x plus 3. I'm adding 3, but now I'm adding 3 inside. Where do you think the function is going to shift? And you are correct. It got shifted to the right 3 units. Okay, so the same effect. Adding 3 inside will move the function to the left 3 units. And then let's say I am subtracting 4, then it will move the function down 4 units. So your new vertex is at negative 3, negative 4. The same pattern will apply up over 1, up 1. Right, and over 2, up 4, because 2 squared is 4. So first you locate your vertex, just like the v, and adding inside the function, shifting it to the left, and then subtracting inside the function is shifting it to the right. All right, so knowing that you will manually actually do this on paper when you are working on your homework and on your test and so on, I am going to go ahead and manually manipulate this equation so you can see. All right, so here, suppose you have x plus 2 squared minus 4. We know that the parent graph is x squared. Okay, and the parent graph of an x squared is a U shape just like that, right? Vertex is at 0, 0, over 1, up 1, over 2, up 4. The same thing, but on the left-hand side, left 1, up 1, because negative 1 squared is 1. Left 2, up 4, because negative 2 squared is 4. So those are our tracking points, okay? And we need 5 points in order to make this nice looking U. So let's go take a look at how this x squared is being shifted. Plus 2 inside the square root is going to move it to the left 2. And minus 4 on the outside is going to move it down 4. Okay, so that means our new vertex is going to be at negative 2, negative 4. So left 2, down 4. here is our new vertex. The new vertex is at -2, -4. Okay, now the same shape is going to stay because we are just shifting and there is nothing else that will affect this function, so the shape is going to stay the same. So that means over 1, up 1, because 1 squared is 1. Left 1, up 1, because -1 squared is 1. Right 2, up 4, because 2 squared is 4. And then left 2, up 4, because -2 squared is also 4. And that will give us this U shape, this parabola there. And that is how you shift a function. So as you can see, if you know the parent graph of a function, you can go ahead and graph the transformation based on the parent function. All right, and we have just learned in this video how to shift. If the inside is positive, it moves to the left, and if the inside is negative, it moves to the right. Okay, now notation wise though, we are going to say if g of x is going to equal to x minus h squared plus k. The reason why we do minus h right here is to denote that inside it does the opposite of what the sign is, and the outside does the same, so the plus k stays. Okay, and that is how the general form of an equation look like. So in the next video, you are going to see how the graph will be stretched, compressed, and maybe even flip over.